Now, before we proceed to our main topic, let's have a short recall on how to reduce fraction. Note that a fraction is said to be in its simplest form when the numerator and denominator are relatively prime. What does it mean? Relatively prime means the GCF, or the greatest common factor among numbers, is 1. So when it comes to a fraction is in its simplest form if the numerator and the denominator are relatively prime, or meaning their GCF is 1. Now, let's try this. What is the simplest form of 27 over 54? So the GCF of 27 and 54 is 27. So 27 divided by 27 is 1. And then 54 divided by 27 is 2. Therefore, 27 over 54 is equal to 1/2. Or the simplified form of 27 over 54 is 1/2. How about 25 and 75? So 25 and 75 are divisible by 25. So 25 divided by 25 is 1. 75 divided by 25 is 3. So therefore, the simplest form of 25 over 75 is 1/3. Now, how to simplify rational algebraic expression, or how can you determine that a rational algebraic expression is already its simplest form? Now, it's similar in fraction. So, to reduce it, just cancel out the common factor between the numerator and the denominator. And also, the expression is its simplest form if the GCF of the numerator and the denominator is 1. So all you have to do is to get the factors of the numerator and the denominator if they are factorable. Okay, let's try this. We have here c squared minus 16 times the quantity of c squared minus 4c plus 16 all over c cubed plus 64. So c raised to the second power minus 16 is a dot. So, or this is difference of two squares. So the factors of c squared minus 16 are c plus 4 times the quantity of c minus 4. Now, how about c squared minus 4c plus 16? Is this factorable? No. It's already a prime factor. So just copy c squared minus 4c plus 16. How about the denominator? So the denominator is c cubed plus 64. So this is a perfect cube, Therefore, this is sum of two cubes. So the factors are c plus 4 times the quantity of c squared minus 4c plus 16. And then, cancel out the common factor of the numerator and the denominator. So in this case, so c plus 4 is common. Also, c squared minus 4c plus 16. Cancel out. And then, that one becomes 1 over 1, 1 over 1. And then, multiply all remaining factors. So that is 1 times c minus 4 times 1 is c minus 4. Then in the denominator, 1 times 1 equals 1, or simply c minus 4. Now, how about this? So the quantity of y plus 2 times the quantity of y squared minus 4y plus 4 all over y minus 1 times the quantity of y squared plus 5y plus 6. So again, Get all the factors of the numerator and the denominator, if possible. Now, for the numerator, so y plus 2, that one is already in simplest form. How about y squared minus 4y plus 4? So it's a trinomial. The first term and the last term are perfect squares. And then the middle term, guys, is equal to twice the product of the square root of the first and the last terms. So that one is PST. So the factors are y minus 2 times y minus 2 or y minus 2 to be squared. Then all over. So y minus 1 is a prime factor, so just copy. And then y squared plus 5y plus 6. So it's a trinomial, but since 6 is not a perfect square, therefore this is not PST. So we will use the trial and error. So factors of y squared plus 5y plus 6. So factors of the first term, so numerical coefficient of y squared is 1, so 1, 1. Then factors of 6. So let's try 3 and 2, then cross multiply. So 1 times 2 is 2, and then 1 times 3 is 3, then add, which is equal to 5, which is equal to the middle term. So therefore, the factors of y squared plus 5y plus 6 are y plus 3 times the quantity of y plus 2. Again, cancel the common factor between the numerator and the denominator. So in this case, y plus 2 is common. So cancel y plus 2. And then, no more. Okay, so again, get the product of all remaining factors. So in the numerator, we have 1 times the square of y minus 2. So that is y minus 2 to the square. And then in the denominator, we have the quantity of y minus 1 times the quantity of y plus 3. Okay. Now, another one. We have here 2 times the quantity of a squared minus b squared times ab plus a to the fourth minus b to the fourth all over a to the fourth minus b to the fourth. Now, look at the numerator. So in this case, there are 3 terms. Now, we can group the numerator. So let's group the last 2 terms. So we have here 2 and then combine 2 and AB. So 2AB times the quantity of a squared minus b squared. And then group the last 2 terms. So the quantity of a to the fourth minus b to the fourth. Okay. From 3 terms down to 2 terms. Okay. And then copy the denominator, so which is a to the fourth minus b to the fourth. And then simplify the numerator. Okay, there are 2 terms. Now, as you can see, guys, a to the fourth minus b to the fourth is a difference of 2 squares. So get the factors of a to the fourth minus b to the fourth. So copy first the first term, so which is 2ab times a squared minus b squared, and then plus, so the factors of this are a squared plus b squared times the quantity of a squared minus b squared. Okay, then all over. Okay, again, this one is similar to that. So therefore, the factors of the denominator are a squared minus b squared times the quantity of a squared plus b squared. And then look at the numerator. So reminders, so this is our first term and this is our second term. Okay? So as you can see guys, there is a GCF, which is a square minus b square. Okay? So factor out the GCF, which is a square minus b square. Then divide. So the first term divided by a square minus b square is equal to 2ab. And then plus second term divided by a square minus b square is equal to a square plus b square. So a square plus b square. Then all over the quantity of a square minus b squared times the quantity of a square plus b squared. Now, in this case, we can cancel a square minus b square. It's because the operation involved here is multiplication. Okay, cancel out a square minus b square. Therefore, we have here, okay, so quantity of, but first, by the way, we need to simplify the expression inside the bracket, so remove the parentheses. So by using the distributive property in here, so we have 2ab plus, so 1 times a square is a square, and then 1 times b square is b square. Then all over a square plus b square. Okay, that's it.